let's now look at some rate of change applications. Okay, and I'm just going to do a few examples here. Let's say a particle moves back and forth along a straight path. According to this function. S represents the position of the particle at time t. So the first thing we want to do is find the velocity at time t. Now, the velocity is a rate of change. It's the rate of change of the distance or position with respect to time. So that is ds over dt, or s prime of t. So the velocity is the derivative of the position or distance. So s of t measures the distance away from zero at any specific time. So the derivative of s is 6t squared plus 6t minus 12. We can factor out a 6 and factor that. Okay, the next thing we can do is let's find the velocity after 3 seconds. So that's v of 3, which is s prime of 3, which is 6 times 5. We're substituting 3 in for t. 3 minus 1 is 2, and that's 60. And the units there are, let's say, feet per second. Let's say we're talking about feet. Okay, so this formula right here gives the velocity at any time, t. Okay, next, when is the particle at rest? Well, when it's at rest, the velocity, v of t, should equal 0. It's not moving anywhere, so the rate of change should be 0. There should be no change. So we solve the velocity equal to 0, and we get t equal negative 2 seconds and t equal 1 second. So negative time, it just means it happens in the past. Okay, when does it move? When does the particle move in the positive direction? So it's moving in the positive direction when v is greater than 0. When the velocity is greater than 0, it's going to move in the positive direction. So if we do another line, this is when the velocity is 0, and then we can pick test numbers to find out what happens in between there. So suppose we pick negative 3, we substitute negative 3 back into for the velocity, and we're going to get v positive. If we pick 0, we're going to get velocity to be negative, and say we pick 2, we're plugging it back into here, the velocity, and we get v to be positive. So it's going to move in the positive direction for t less than negative 2 and t greater than 1. So from negative infinity to negative 2, and from 1 to infinity, we're moving in the positive direction. The negative direction is when the velocity is negative, and that's between negative 2 and 1. So let's draw a picture of this. When t equals 0, the position of the particle is at 0. So we start here at 0, 0. At t equal 1, the position s of 0 is 0. The position we substituted back in is negative 7. So here, let me draw this. So this is t equals 0. We're at 0. T equal 1. We're at negative 7. So we're going this way. At, let's say t equal 2, we're going to be at 16 plus 12 minus 24. So we're going to be at 4. So we're turning around here. And we know we turn around at 1 because that's where the velocity is 0. So this is where v is 0. And let's do s of 3. So we're going to be way over here at 45. Okay, let's do negatives. At negative 1, we're going to be at 13. So let's do this. At negative 2, we turn and change direction. So that's going to be 20. And one more. So that's going to be 9. So we change direction here, and we come back to 9. So we're going in the positive direction till we get to negative 2. Then we go in the negative direction from negative 2 to 1, time-wise. And then we change direction at negative 2 because that's when the velocity is 0 at this point. And then we come back and continue in the positive direction. So that's how we're moving back and forth. Again, this is a straight line. So essentially what we're doing is going here to -2, then coming back, and then going forward on a straight line. So that's what the path of this looks like. And you can tell that with the rate of change. So in the first 8 seconds, what's the distance, total distance? Let's just do this. Let's do in the first 3 seconds. So at between 0 and 1, the distance covered, it goes from 0 to -7. So the distance is 7. And then from 1 to 3, at 3 we get 45. So it went from -7 to 45. This went from 0 to -7 distance-wise. So that's 45 plus 7 is 52. So it went 52 units because it had to come back and cover that other 7. So the total distance is 59. So you have to do the absolute values to find distance because distance is positive. So what we have to do is if we want to count this is going to be 7. Here's another 7, and then there's 45. So we have to add all that up. 7 plus 7 plus 45. Okay, so in this case, the rate of change tells us is the velocity, okay, change in distance over change in time, and that tells us how this particle travels on a straight line. Now let's try another one. Okay. The ball is thrown up vertically in the air, so it's thrown straight up with initial velocity, that means when it starts, (64 feet per second). Its height after t seconds is this. Okay. What is the maximum height? Well, when you throw a ball up in the air and then it comes back down, at the top, right here, the velocity is 0. It's at rest when it changes direction. So we know to reach the maximum height, we want the derivative to equal 0. So the derivative of this function is -32t plus 64. That's equal to 0. So t is equal to 2. In 2 seconds, it'll get to the maximum height. So the next question is, how high will it go? So if we know it reaches the maximum height in 2 seconds, then that's s is our height, so s of t is going to be minus 16 squared plus 64 times 2 plus 5. And that's going to be minus 64 plus 128 plus 5, and that's going to be 69 feet. Okay, from what height was it thrown? Well, it was thrown at time 0, and s's height So S of 0 is 5 feet. So that makes sense. If you're 5 feet tall, 6 feet tall, or whatever, you're throwing it from a height of 5 feet. With what velocity does it hit the ground? Well, you have to find out when it hits the ground. And again, you're throwing it up in the air and you're coming back down. So the ground, your height, is 0 on the ground. So S of t equals 0. You're just changing the English into math symbols. So we have negative 16t squared plus 64t plus 5 equals 0. And to do that, we'll use the quadratic formula. So we have negative b plus or minus the square root of b squared minus 4ac all over 2a. We're going to get two answers. Let me use my calculator. Okay, and that comes out to be, the positive answer we want is 129.2, say. So about 129. Oh, wait a minute, that's not right. That doesn't make sense. Okay, it's about 4. Using the calculator correctly. Okay, so this is about 4.06, so we'll say it's about 4 seconds. So it's going to hit the ground in about 4 seconds. So we know f of 4 should be 0, and the velocity at 4, we're going to plug back into the derivative. And that comes out to be negative 64. Now it's okay that velocity is negative, that means it's coming back down. So when velocity is positive, it's going up. Here velocity is 0, changes direction. When it comes back down, your velocity is negative. And that should make sense because this is rate of change. And these, remember, are the slopes of the tangent lines. And going up, your slopes are positive, and coming down, your slopes are negative. So what you have to remember here in these problems when you do them is that rate of change is a derivative. Whenever you hear the rate of change, they're asking you for the derivative. And if it's dh over t, this is height, the change in height with respect to time. If it's dm, dt, usually it's with respect to time. It's the change in mass over the change in time. It could be anything is the point. And you could have dv over dr, the change in volume over the change in the radius. So your derivative measures the rate of change of some quantity, height, volume, mass, anything pretty much you can think of. So look at some of the example homework problems.